very important session in the Game Changers series for RRB JE 2024, where I'm back again with some very important questions, mixed question practice of thermodynamics, applied thermodynamics and fluid mechanics. Hi Rachit, good evening, welcome to the session. So good evening my friends, good evening, welcome to the session. I hope all of you are getting the clear audio and video and nobody is facing any problem in that. Yes, please let me know if you are having clear audio video. Just respond me in the comment box. Yes, good evening everyone, good evening. Welcome to this session. So this is fourth session of mixed question marathon, where we are providing you questions on different subjects of mechanical, mainly which I will be teaching you. You know that those are my expertise subject. Those subjects are thermodynamics, applied thermodynamics and fluid mechanics and machinery. So we will be practicing questions on these subjects, and so please everyone quickly join me for this session. Very good evening, welcome to the session. So good evening my friends, welcome to this session. Just give me a thumbs up if you are getting the clear audio and video, and then we can start the session. Well, I can also see that students are still joining in the session. I can see right now we have just 3 students live in the session, so I'm just waiting for you to quickly join me for this session, and then we can start the session. Yeah, Sagar, good evening, welcome to the session. Good evening, Sagar. Well, just a second. Today is 12 September, 8 p.m. Okay, everything is clear. Okay, fine. Thank you so much for your response. Thank you. Let's begin the session. Let's start. So my dear students, if you have joined me for the first time and you have not yet subscribed to our YouTube channel, then please do that. Take out few seconds. It will just take few seconds for you to subscribe the channel, and also less than 20 seconds to like the session, and maybe around 30 seconds to share the session. So total it will take 1 minute. So if you can give some time and perform any of this operation, it will be nice, and it will be better if you basically like and share the session, because it's good for the engagement, because we'll be having more students, right? And you can also compete with other students. Some of the students were also asking, sir, can you take poll based sessions on YouTube? See, on YouTube it is not possible, but I will see how I can give you those kind of session. Okay, we can plan those kind of session. One more thing, that as you can see in the chat box, our team is sending the message that if you need any guidance regarding RRB JE preparation, then you have to fill a form that is provided in the chat box. You can fill that Google form, and from that, based on your response, we will provide you the guidance regarding RRB JE exam preparation. Okay. Also, please do not forget to subscribe to our YouTube channel, download our Resultant app, and also do join our Telegram channel of mechanical, Resultant ANJ Mechanical. Do join it so that you never miss any videos from that. Whatever kind of video we are providing, whether it is technical, non-technical, or any kind of PDFs are shared, everything will be shared in our Telegram. So please do not forget to join our Telegram. Hello MS, good evening MS, welcome to the session. Let's start the session. So this is my introduction for those students who have who are watching this session for the first time, and you have come to this YouTube channel for the first time. If you don't know any information about me, then that's all I can tell about myself. I am Vikas Sir, having over 7 years of teaching experience, and these are the subjects I have taught so far from the last 7 years. I have also done my MTech in thermal engineering, and so based on my expertise, I am teaching these subjects, and I have mentored more than 1 lakh students for these exams. Hello Ravi Ranjan Kumar, good evening, welcome to the session. Let's come to first question of today's session. It's already 7 minutes. 7 minutes have passed, so I think we should not delay in practicing the questions now. I think And also we have 8 participants in the session. 8 students have joined the session. So let's begin the session. Which of the following statement about an impulse turbine are correct? Impulse turbine, you know something about the impulse turbine? In the impulse turbine, the nozzle of the impulse turbine converts, entire pressure energy into kinetic energy. That is, it converts entire pressure energy, all the pressure energy into kinetic energy. So that is very big thing about the nozzle of the impulse turbine. So basically, when this nozzle will do this conversion, then what will happen to the blade? Now what will happen? The blade of the impulse turbine, will only be having one thing, that is, they will be having kinetic energy. They will be getting only kinetic energy. Will they be having any pressure energy? They will be having no pressure energy. The pressure will be constant. They will be having no pressure energy. So pressure will be constant on the blade. On the blade, pressure will remain constant. Pressure and heat both drop in the nozzle, correct. Expansion steam occur in the nozzle only, correct. Expansion steam occurs in the moving blade. This is wrong. The right answer is option A and B for this question about the impulse turbine. Yeah, yes, Ravi Ranjan, I think maybe you are late for this information, but you are asking about the poster. He has already joined. He is already a JE in railway. Okay, he has joined as a JE in the Indian Railways, for which you are preparing right now. Okay, so it's great also, because if you will get selected in the RRB JE exam, then definitely Bose sir will be, you can find Bose sir over there. Okay, so he will be there in the Indian Railway waiting for you. Which statement best explains why real gases deviate from the ideal gas law at high pressure? Well, as you know that we say that real gases behave as an ideal gas, at high pressure, at low pressure and high temperature. At low pressure and high temperature, the real gas behave as an ideal gas, right? Now, here they are saying that real gases will deviate from the ideal gas at high pressure. Yes, if you see the real gas at high pressure, then that real gas will not be following the ideal gas behavior. It will deviate, means it will not follow the ideal gas behavior. What is the reason behind that? Reason is, at high pressure, the gas particle occupy a negligible volume. No. Intermolecular force becomes negligible at high pressure. No. Gas particles have finite volume and experience intermolecular attraction. Yes. This is the reason. Because these are the conditions when a real gas behaves as an ideal gas. Deviate means not following something. So real gas will not follow ideal gas behavior when the pressure will be high. Why? Because there are few assumptions we follow for the ideal gas. Those assumptions are, when the pressure is low and temperature is high, then the ideal gases will have negligible volume and there will be very less force of attraction. But a real gas will be having some volume and it will experience the intermolecular attraction. Okay. Consider a multi-stage air compressor operating under ideal condition. If each stage of the compressor is designed to have same pressure ratio in the multi-stage compressor. Suppose we are having a multi-stage compressor, and in the multi-stage compressor the pressure ratio in each stage is equal. Okay, so this is first stage compression, this is second stage compression, this is third stage compression, and between each stages we are using a intercooler between each stage. What we are using here? We are using intercooling between each stage. In this question, it is mentioned that same pressure ratio. What is the meaning of same pressure ratio? Same pressure ratio, if there is same pressure ratio in each stage, if the pressure ratio is same, that means the intercooling becomes perfect. The intercooling becomes perfect, and if the perfect intercooling is there, then whatever efficiency, the efficiency will increase as the number of stages will increase. The efficiency, which efficiency? The volumetric efficiency will increase. As the stages of compression will increase, the volumetric efficiency will increase. So the right answer will be option D will be the right answer for this question. So if you increase the number of stages of compression with perfect intercooling having same pressure ratio, then volumetric efficiency will increase. Next question. Consider the following statement with regard to hydraulic turbine. Kaplan turbine are most efficient at part load operation. Kaplan turbine, as you know, it comes under the classification of axial flow turbine. It is a axial flow turbine and it has adjustable blades. It has adjustable blades. Because of having the adjustable blades in the Kaplan turbine, it has part load efficiency. It has got part load efficiency. What is the meaning of part load efficiency? That means these are two conditions in which you can operate the turbine. One is you can operate a turbine at full load, or any device you can operate either at full load or full potential, or you can operate it at part load. And that is for any type of work producing device, whether it is turbine or engine. Even for the engine also, you can operate the engine at full load, part load, half load, right? So because of having adjustable blades in the Kaplan turbine, they have better part load efficiency. So that is correct. If n is the number of jets in the Pelton turbine, then the specific speed is proportional to square root of n. See, a specific speed formula is n root of n into p divided by h power 5 by 4. This is a formula for a specific speed, and in this formula n represents number of jets. Then specific speed is proportional to square root of n. Is it proportional to square root of n? Yes, this is correct. The flow ratio of a Francis turbine is between 0.1 to 0.4. Which of the following will be correct? Do you think the flow ratio is between 0.1 to 0.3? Yes. They are asking about the Francis turbine. Exact database question they are asking here. The flow ratio of the Francis turbine is 0.15 to 0.3. Yes. So this is also correct. All the points are correct. Okay. What is flow ratio? The flow ratio is equal to flow velocity divided by the square root of 2gh. This is called flow ratio. This is also called speed ratio. Speed ratio is equal to blade speed divided by the square root of this. Okay. Now this is called as speed ratio. Speed ratio of the Francis turbine is between 0.6 to 0.9, but the flow ratio is from 0.15 to 0.3. Okay, clear? So maybe next time they can ask you, yeah, this is 0.15 to 0.3. So this is also correct. Okay, all the options are correct. For linear distribution of the velocity in the boundary layer on a flat plate, what is the ratio of displacement thickness to the boundary layer thickness? Yes. What is the meaning of linear distribution of the velocity? Linear distribution of the velocity means that there is something called velocity profile. Whenever a fluid flows over a surface, then the fluid will follow some profile, which is because of the flow behavior of the fluid, which is u by u infinity is equal to y by delta. This is called as this equation of the, this is called velocity profile, and this is called linear velocity profile. Now for this linear velocity profile, they are asking the ratio of displacement thickness to boundary layer thickness. What is displacement thickness, my friend? It is integral of 0 to delta 1 minus u by u infinity of dy. In this question, as you know that this is a linear velocity profile, so this will be 0 to delta 1 minus y by delta dy. If you integrate this, you will get this as y minus y square by 2 delta. And if you put the limits 0 to delta, you will get this as delta minus delta square by 2 delta. This will be delta by 2. So displacement thickness is equal to delta by 2. And you have to find the ratio of displacement thickness to boundary thickness. This will be delta by 2 by delta, which is 1 by 2. So 1 by 2 will be the answer. Clear? 0.5, yes, 0.5. MS, you are giving right answer. Very good. Sagar, Ravi Ranjan, everyone, all of you have Rachit, Renault. Yeah, most of you are giving the right answer. Very good. Next question. A jet of water having 50 mm diameter and velocity of 20 meter per second strikes normally on a flat surface. So basically we are having a flat surface, or we are having a flat plate, and the jet is coming, and basically this jet is falling on this plate normally. What is the velocity? The velocity of the jet which is striking the plate is equal to 20 meter per second, and the jet diameter, the diameter of the jet is equal to 50 mm. If the plate is moving in the same direction, now because of this impact, this plate is also moving in the same direction. The velocity of the plate is 8 meter per second. The work done per second on the flat plate. What is the work done per second in watt? How you will find the work done per second? I want all of you to firstly answer the question, and after that I will definitely, obviously I will give you the answer. So everyone try to solve it. Just tell me what approach will be used here, how you can find the work done per second on the flat plate. So on this plate, when the jet will impart force on this plate, the force will be applied. There will be normal force. Okay, so work done will be normal force into the velocity of the plate. This is u. So this will be the work done. You just need to find the normal force. Okay, because plate velocity is already given. Options are so close. Yeah, options are very close. So what will be the right answer? Okay, so many of you have given the answer as option A. Okay, let me check if the right answer is option A. The normal force, this is the normal force applied by the jet on the plate. This is equal to rho into A into V minus U whole square. This is called relative velocity. Okay, so when the jet will strike the plate, now the plate will move with a relative velocity in the same direction, right? Are you getting this? So this will be, density is 1000, area will be pi by 4 into d square. D is diameter, which is 50, 0.05 square into what is velocity? Velocity is 20 minus 8 square. You can get the normal force, you will get the force from here, multiply with the force with the velocity of the plate, this, and you will get the work. Tell me what is the answer. Okay, many of you are getting option A. So now I have to verify whether it is option A or not. Okay, so you will get this as 282.74 Newton, and if you multiply with 8, you will get 2261.952. So this value will be the, yeah, you will get this as the answer. Very good. All of you are correct. Identify the correct statement regarding no slip phenomena. Have you heard about the no slip phenomena? Yeah, whenever a fluid moves on a plate or on any surface, on a plate, on a pipe. So let's say the fluid is moving on a plate, on a surface. Then the fluid particles which are very close to this surface, let's say this is a surface. The fluid particle which moves very close to this surface, it looks like, although these fluid particles will be having some velocity, but because this is a stationary surface, stationary solid surface, okay, so because it is a stationary surface, and although the fluid is having some velocity, but because of no slip condition, what is the meaning of no slip? Because of the no slip condition, it will look like this fluid particle very close to the surface has taken the velocity of this surface, which is 0, right? So at this point, you will say that fluid will be having 0 velocity. Okay. So what is the answer for this question? It is shown by non-viscous fluid. Okay. First of all, they are saying it is shown by non-viscous fluid. Viscous fluid or non-viscous? Tell me, is the fluid viscous or non-viscous? Non-viscous means not having viscosity. This is wrong, because obviously fluid will be having some viscosity. Okay. So this is not correct. Option A is not correct. Shown by viscous fluid at the interface of other fluid by making a visible separation between the two fluids. No, not related to fluids. It is not with respect to two fluids. It is shown by that, because the meaning of this statement is that they are saying that this no slip condition is with respect to two fluids. This is fluid number 1 and this is fluid number 2. So is this with respect to two fluid? No, it is with respect to, it is shown by viscous and continuous fluid when it moves over the solid surface. It is shown by when a viscous and continuous fluid, continuous means continuously moving fluid, when it moves over a solid surface, then this no slip condition happens. Now, no slip can happen on a flat plate, even it can happen on a pipe surface also. Suppose this is a pipe. So the fluid particle which will float to the close to this pipe surface, they will be having no slip condition. So here also no slip apply. Here also no slip condition applies. Okay. For an isolated system executing a process, in the isolated system basically no heat transfer take place. No work is done. No mass crosses the boundary. No chemical reaction take place within the system. Which of the above statements are correct? For an isolated system, which of the following statement is correct? See, you know that isolated system is a system in which no energy and mass interaction. So energy and mass interaction will not be present, that is for sure. So this is correct, this is correct, this is correct. Yeah, these three all are correct. What about this? No chemical reaction take place within the system. See, isolated system will not be having any energy interaction and mass interaction, but not be having any kind of chemical reaction inside the system. That is not correct. So this is not correct. The answer is option A, because an isolated system can have chemical reaction inside the system. Okay. Although because of that chemical reaction, there will be no energy transfer in the form of heat, work, and even there will be no mass transfer. All these are correct, but this is not correct that they will not be having chemical reaction. There can be chemical reaction inside the isolated system. Okay. At location 1 of a horizontal line, this is wrong, it is not horizontal line, it is horizontal pipe. At location 1 of a horizontal pipe, the fluid pressure head is 32 centimeter and velocity head is 4 centimeter. the reduction in the area at location 2 is such that the pressure head drops to 0. The ratio of the velocity at the location 2, so what is they are asking here? In this question, the question is somewhat like this. The question is somewhat like this. All right. So basically, at location 1 of a horizontal pipe, this is location number 1, the pressure head is given, velocity head is given. The reduction in the area at location 2. So here at location number 2, the area is reduced. And how it is reduced? Such that pressure head, here the pressure head is 0. And here they have given the pressure head as, and velocity head is given. It is 4 centimeter and this is 32 centimeter. They are asking the ratio of velocity at location 2 to that of location 1. So basically, you have to find the ratio of velocity of 2 with respect to 1. How are you going to find this? Tell me. So first, Bernoulli equation will be applied between, first we will apply the Bernoulli's equation between section 1 and section 2. So if we apply the Bernoulli equation between section 1 and section 2, it will be P1 by rho g plus V1 square by 2g plus Z1 will be equal to P2 by rho g plus V2 square by 2g plus Z2. Now, because this is a horizontal pipe, for horizontal pipe Z1 will be equal to Z2 for horizontal pipe. Okay. In case of horizontal pipe, Z1 will be equal to Z2, this will be 0. P2 by rho g, the pressure head is already 0 at section 2, this is already 0. Okay. So what we are left with, this is P1 by, this is already given 32, this is given as 4, V2 square by. So from you will get, here you will get velocity. What is velocity at point section number 2? Come on, tell me. What is the velocity at section 2? So you will get somewhat like 26.57 meter per second. And if you know the V1 square by 2g, if you know V1 square by 2g is equal to 4, so velocity V1 you will get from here, it will be it will be 8.85. So just this value will be 26.57 divided by 8.85. The answer will come out to be you will get 3 as the answer. The answer will be option A, 3. Are you all getting the same value? Option A, 3. If you are, then very good. Next question. A frictionless piston cylinder device contains 5 kg of steam at 400 kilopascal and 200 degrees Celsius. The heat is now transferred to the steam until the temperature reaches 250 degrees Celsius. If the piston is not attached to a shaft, its mass is constant, and by taking the value of a specific volume V1 and V2 as this, work done by the steam during the process. That can be also done. See, I always give the explanation which is very simple. Okay, I always try to give the simplest explanation. You can also do that. You can directly find the ratio of velocity head. Okay, whatever suits you. You can V1 square by 2g, V2 square by 2g divided by V1 square by 2g. From there also you can, it will be V1 square by V2 square by V1 square. and then you can get the square root. That is well, also very easy approach. Yeah, you are correct. Okay, so that approach is also fine. That v1 square, this is 4, that is 36. 36 is 4, that will 9. Okay, and from there you can square root of 9 will be 3. So simply you can get the answer. Okay, so that is also great approach. v2 square by 2g divided by v1 square by 2g will be equal to 36 by 4, that is 9. This will get cancelled out, so you get v2 square by v1 square is equal to 9. So v2 by v1 will be 3. Okay. In this question, there is a frictionless piston cylinder device. Okay, and that frictionless piston cylinder device contains 5 kg of steam at 200 degrees Celsius, and in this steam you are transferring the heat. Because of that, the temperature has increased to 250. The piston is not attached to a shaft. Sorry, if the piston is not attached to a shaft, its mass is constant. So mass is constant by taking the value of specific volume and work done by the steam. So work done will be equal to C. When the heat will be supplied, this obviously this piston will move, it will expand. So because of that, the work will be at constant pressure. Constant pressure work will be pressure into change in volume. Okay, so you can get the work as pressure. Pressure is 400 into change in volume will be mass into change in specific volume. So directly the work will be equal to 400 into 5. Change in specific volume will be V2 0.59520 minus 0.53434. Solve it, you will get the answer. Okay. So you will get answer as 121.72. Okay, option A will be the right answer. Clear? All of you are getting the same value? Tell me. Now you must be thinking, sir, why have you applied the work for constant pressure only? Because if there is no shaft attached to this, right? So we are not doing any kind of shaft work. So in that case, piston will be free to move. So when the heat will be supplied to this, although pressure will increase, but because the piston will move, overall the pressure will be remain constant. Pressure will remain constant. So that is why this is a condition of constant pressure system. And for constant pressure, you can find the work by this relation. Here specific volume is given, mass is given, the pressure is kept constant, it is also given. A pump consumes 2 kilowatt of power when operated at 4000 RPM. How much power it will consume when being operated at 12,000 RPM? Well, in this question, you have to find the relation between power and speed of a pump. Is there any relation between power and speed of a pump? Let's say we are talking about centrifugal pump. Okay. For a centrifugal pump, is there any relation between the power and the speed? You must have seen many relations of the in the case of pump. It is P over D5 N cube is equal to constant. This is a very popular relation, and based on this relation, you can say the power and speed are directly related to each other. So P2 by P1 will be equal to N2 by N1 cube. Okay, so N2 is 12,000, this is 4,000 cube (27) P2 by 2. So you will directly get this as 54. Okay. Next question. Efficiency of the vapor powered Rankine cycle can be increased by. How can we increase the efficiency of vapor powered Rankine cycle? Increasing the temperature of the working fluid at which heat is added. What is the meaning of temperature of the working fluid at which heat is added? That means we are talking about mean temperature of the heat addition. So basically in the vapor powered Rankine cycle, if you increase the mean temperature of heat addition, then you can get more efficiency. So mean temperature of heat addition if increased, mean temperature of heat addition if increased, then you can get more efficiency. Increasing the pressure of the working fluid, that means the boiler pressure we are talking about. If we increase the boiler pressure, then also efficiency will increase, right? Decreasing the temperature of the working fluid at which heat is rejected. This is the temperature at which heat is rejected. If you decrease this temperature, increase this temperature, increase the boiler pressure, all these factors will increase the efficiency. All are correct. Okay. In a steady flow compression process, the increase in the specific enthalpy is 20 kJ per kg and decrease in the kinetic energy is 2 kJ per kg. The rate of heat rejection to the surrounding is 5 kW and mass flow rate of the gas is 2 kg per second. The power required to compress the gas is. Yes, how we are going to approach this question? Obviously, it is a case of steady flow energy equation. Yes. And also, if you have any new student has joined and you have not subscribed to our channel and press the bell icon, like the session, do all these things if you have time, whenever you have time. In this question, what is the meaning of the statement? Increase in the specific enthalpy. Increase. How you rise? Increase in something. Increase means this. H2 minus H1, right, is equal to plus 20. And decrease in the kinetic energy means that is difference of the final kinetic energy and initial kinetic energy, that is equal to minus 2. A rate of heat reaction to the surrounding. Heat reaction is obviously minus. And mass flow rate is given 2 kg per second. How you are going to find the value of power? So simple relation, we apply the steady flow energy equation, mass flow rate H1 plus V1 square by 2000 plus Q is equal to mass flow rate H2 plus V2 square by 2000 plus power. Now, from here you will get the mass flow rate H1 minus H2 plus V1 square minus V2 square by 2000 plus Q dot is equal to power. Now, mass flow rate is equal to how much? 2. So, just put 2. H1 minus H2 will be, if this is plus 20, then H1 minus H2 will be minus 20. V2 square minus V1 square is equal to, by 2000 is equal to minus 2. So, this will be plus 2. If this is minus 5, put minus 5. What is the value you are getting? This is minus 20 plus 2, that is minus 18 into 6, minus 36 minus 5. So you will get power input is equal to minus 41 kilowatt. That is option C will be the right answer. Clear? Option C. Are you all getting this value? Tell me. So this kind of question can also come in the exam where they can give you the increase or decrease in some quantity. Always remember, when they are saying increase in something, that means difference between the final and initial value is positive. If it is decrease, then that means difference between the final and initial value is negative. In a compression ignition engine, air is compressed from 30 liter to 1.4 liter. From initial pressure of 1 bar, the mean effective pressure is 520. Net output of the cycle is in kilojoule. So You know that mean effective pressure is equal to net work by sept volume. We can simply use this formula and get our answer of net work. This mean effective pressure is given as 520 kilopascal. Yes, minus 41. Why minus 41? That means it is a compression work. It is work input. Negative sign, what in negative sign represent? This is compression work. Okay. So compression work, obviously it will be negative. So this is given. Net work you have to find. If you know the value of sept volume somehow, if you get this value, you can get your answer. So how to get the sept volume? In compression ignition engine or diesel engine, the air is compressed between these 2 points. From point 1 to point 2, the air is compressed, and the volume at point 1 is 30 liter. And at point 2, after compression, the volume is 1.4 liter. So this is also called as total volume, which is sept volume plus clearance volume. This is known as clearance volume. So V1 minus V2 will be equal to sept volume. So net work will be simply equal to 520 into 30 minus 1.4 into 10 power minus 3. Solve it, you will get the answer. Most of you have already solved. So let me also so you will get 14.8 kilojoule. Okay, clear? Next question. Steam expands in a turbine from 40 bar 500 degrees Celsius to 0.10 bar isentropically, assuming ideal condition, given enthalpy drop is 1198.8 kilojoule per kg, nozzle angle is 16 degree, and RPM is 300. Mean diameter of the wheel if turbine were of simple impulse stage will be. So much data is given, right? Question looks confusing, but it's not. It's a very simple question. So in this question, it is mentioned that isentropically the pressure is getting dropped from 40 bar to 0.10 bar in a turbine, right? Assuming ideal condition, the enthalpy drop is given. So how to find the diameter? You know that blade speed is equal to pi dn by 60. If you get the value of blade speed somehow, then this is given as 300. This is pi d. You can get the value of d from here. But how to get the blade speed? Now, for simple impulse turbine, the blade and speed ratio is equal to cos alpha by 2. We will be getting this value. Now 16, alpha is given as 16, so this will cos 16 by 2. From here you will get the ratio of blade speed and jet speed. Now, so it is very obvious that if you get the value of jet speed, your problem will be solved. So how you will get the jet speed? Jet speed will be square root of 2000 into delta H. Delta H is already given in this question. So you will get this as square root of 2000 into 1198.8. From here you will get the value of jet speed in meter per second. From here you will get blade speed in meter per second. And if you put it here, you will get the diameter. Clear? Okay. Everyone, I request everyone to take out few seconds to solve it. Don't be in a haste of, sir, it's taking so much of time, let's not solve this question. Don't do that. So you will get this value as 1548.41 meter per second. And if you solve this value, cos 16 degree divided by 2 and into 1548. So you will get blade speed as 744.21 meter per second. Put the blade speed here in this relation. If you put the blade speed here, 744.21 is equal to pi, which is 3.14 into d into n 300 by 60. So you will get I think there's a mistake here. Are you getting 4.73 or 4.96? What value you are getting? Yeah, tell me. By solving this, you will get 4.7. You will get diameter as 4.73 meter. Okay. Yeah. That will be, and here's a mistake here. I think this is 3000. This should be 3000 RPM because otherwise you are getting 47.3. So this has to be 3000, not 300. Okay. This has to be 3000. RPM is wrong because if it is 300, if we keep this value as 300, then you are getting 47.3. Then you will get 47.3. Okay. But this is wrong. This should be 3000. If you keep it 3000, you will get 4.73. Okay. So that is the catch here. This will be 3000. RPM has to be 3000. Next question, the PV diagram of diesel cycle is shown in the figure. Well, not shown. Let me show you. This is a pressure volume diagram of a diesel cycle. Okay. Now it is shown to you. All right. 1, 2, 3, 4. The PV diagram is shown to you of diesel cycle. The temperature at some different points. At what point temperature is given? T1, T2, T3, T4 all are given. You have to find the efficiency of diesel cycle. How to find the efficiency of diesel cycle? Efficiency of the diesel cycle, you have always remembered this equation. Now 1 minus 1 by gamma of compression ratio power gamma minus 1 into cutoff ratio power gamma minus 1 over cutoff ratio minus 1. This is a formula you have always remembered, right? But for solving this question, we will not be using this formula, my friends. We will not be using this formula for solving this question. Which formula will be used then? Well, how you get this formula? What was the basic behind this formula? The basic was efficiency can be written as 1 minus heat rejected by heat supplied. 1 minus heat rejected. What is heat rejected? Where is heat rejected? Heat is rejected at constant volume, right? Which is equal to mCV T4 minus T1. And heat is supplied at constant pressure. Heat is supplied at constant pressure, which is equal to change in enthalpy, which is equal to mCp T3 minus T2. Heat is rejected constant volume, which is equal to change in internal energy, which will be equal to mCv T4 minus T1. Let's put this value mCp T3 minus T2. By solving this, you get this formula, but here this will be 1 minus Cv T4 minus T1 over Cp T3 minus T2. Everything is given. Cv is given, T4 is given, T1 is given, so everything is given. Just put the values and get the answer. Understood? In this question, everything is given. Just solve it. Just put all the values and get the answer. T4 minus T1. T4 is 1090 minus T1 is 290. into CV. CV is 0.7. So you will get this value as efficiency will be 1 minus 560 divided by T3 minus T2 is 2030 minus 830 into 1. Oh, this will be 1200. Simply so you will get 54%. So you will get 54, approximately 54, that is option C. Okay. Are you all getting this value? Everyone? Those who have joined me for this session? Do not forget to like and share the session. Next question. A steam turbine receives steam at 15 bar, 350 degrees Celsius, having enthalpy and entropy as this, and exhaust to the condenser at 0.06 bar. At 0.065 bar, the enthalpy and HF, HFG, SF is given. What will the approximate efficiency of the ideal Rankine cycle between these two limits? Neglect the pump work. How you will find the efficiency of the Rankine cycle? So, in this question, they have given that at 15 bar pressure, at this particular point, point number 1, the enthalpy is equal to 3147.5 and entropy at point 1 is equal to 7.1. Okay, and at 0.06 bar, HF here, HF will be this, HF is equal to 151.5 and HFG is equal to this 2416. SF is given, everything is given. How to find the efficiency? So efficiency will be equal to net work divided by heat supply. Net work will be equal to turbine work minus pump work divided by heat supplied. Pump work is neglected, so this will be turbine work by heat supplied. Turbine work you can get from here is H1 minus H2. Heat supplied is from, let's say this is 1, this is 2, this is 3, this is 4. This will be H1 minus H4. Only two things you need to get. One thing is H2 and second is H4. How to get this value? Let me make it very simple for you. See, pump work is equal to H4 minus H3. Since pump work is 0, so H4 will be equal to H3. H3 is equal to HF. So pump work will be equal to 151.5. This will be the value of pump work. Now, turbine work. For turbine work, H1 is already given. If somehow you get the value of H2, your answer will be solved. Now, H2 is in the wet region. H2 will be equal to HF plus X times of HG minus HF. Or directly you can say HFG. HFG is given now. So you can directly write HFG. Only problem in solving this question now is sorry, why I am doing this. H4 is known to you, H1 is known to you, only problem is H2. But to get the value of H2, you need to get the value of dryness fraction. How you will get dryness fraction? Any idea? Any idea? Anyone can tell me? Any one of you? Let me just hide myself because I want the question to be explained here only. Yeah. So you know that 1 to 2 is isentropic process. So entropy at point 1 will be equal to entropy at point 2. Entropy at point 1 is 7.1. Entropy at point 2 is in the wet region. That will be SF plus X times of SFG. Right? So from here you will get value of X. Right? SF and SFG is given. Get the value of X. Put the value of X here. You will get 151.5 plus X into 2416. You will get H2 from here, X from here, and your answer will be, you will get the answer. Tell me, what is the dryness fraction? So dryness fraction will be 0.843. Okay, 0.843. Put the value here, you will get this value will be 2189.61. Okay, so now you will get the efficiency from here. Put all the values, you will get efficiency. What will the efficiency? So you will get efficiency at 31.97. Okay, simple question, but maybe the calculation was little bit tough. But if there will be some question in the Rankine cycle in the exam, so this can be the question. Okay, clear? Understood everyone? Next question. Let's take this question as the last question of today's session. Okay, after this we will take one more question, that's all for today. A rectangular plane surface of width 2 meter and height 3 meter is placed vertically in the water. What will be the location of the center of pressure of the surface when its upper edge is horizontal and lies 2.5 meter below the free surface of water? So basically we are having this free surface of the water. So this is water everywhere, and this is, let's say, free surface. And we are having a rectangular plane surface. A rectangular plane surface is such that how much? 2.5 meter. 2.5 meter below the free surface. From this point, we are having this rectangular surface like this. This height is 3 meter and this is of course 2 meter. You have to get the value of center of pressure. Center of pressure you have to get. Center of pressure is that point where the hydrostatic force acts. That point is called center of pressure. Center of pressure is equal to, you know, our direct formula for center of pressure, that is equal to, do you know the direct formula? It is Ig, over AH bar plus H bar. What is H bar? H bar is the position of centroid, and centroid position will be, centroid will be 2.5 meter plus half of this, that is 3/2. You will get this value as 4 meter. This will be the position of centroid of this, because this submerged plane vertical surface is at a distance of 2.5 meter below the free surface. So total centroid position from this free surface will be, centroid will be somewhat here at this point. At this point it will be centroid. So that is, this is 1.5 plus 2.5. So at this point you will get position of centroid, that is 4 meter. Okay, moment of inertia will be, about the centroidal axis, moment of inertia will be B into H cube by 12. Simply B is here, how much? Width is 2 meter and H is 3 cube by 12. So you will get moment of inertia from here. Area will be equal to, area will be 3 into 2, of course. From here you will get area. Just put everything, you will get the answer. So what value you are getting? Yes, come on. 0.5 you will get 4.1875. Okay, so that will be the answer for this question. Clear? So with this, I will end the session, and rest of these questions I will take for the next session. I want to tell you one thing, that tomorrow there will be a class tomorrow at 8 p.m. but for next week I will be on off. Okay, so basically I will not be taking any session next week. Okay, so maybe some other faculties, maybe Dheeraj sir or Suraj sir will be taking YouTube session in the next week. I'm going for some place for 1 week. So for next week you will not get any class, but tomorrow at 8 p.m. you will get my session. Okay, so thank you so much. That's all for today, and next week don't wait for me. I will definitely be available after the next week. So my next class after tomorrow will be on 23rd. Next class after tomorrow on 23rd. My next class will be 23rd September 2024. But tomorrow I will be taking the class at 6. Yeah, I will come back obviously after 1 week. Okay, don't worry. So thank you so much. Have a nice day. I will see you tomorrow at 8 p.m. Thank you. Take care. Have a nice day.